Lunch and Learn is going to be around Covéa core microservices. Why are we doing microservices? How are we doing them? What are the benefits? How are we going to evolve what we've done already? So I'll be covering some of those things. Just a bit about me. This is me. There's a picture of me this morning and a picture of me from last year, halfway up Kirkstone Pass in the Lake District, looking down and thinking, oh Jesus, I've got to ride down that slippery, narrow, tight, twisty road on this motorbike. I am the chief architect at Covéa. I've been here for 1.5 years now. My responsibilities as chief architect, along with Simon Hickling, who's the chief architect for Solution, and Martin Dennehy, who's the chief architect for Enterprise, is to look after the platform offerings, of which microservices form a part of that. I've had a background in software development, so I started my IT life as a software developer. That moved into technical consulting and architecture, into my current role, where I am at Covéa now. I am genuinely interested in technology. I will quite happily talk about technology and architecture, the platforms, the tools, as much as anyone likes, but away from technology, as you can gather by the photograph, I really do like motorbikes, and we'll also talk about those till the cows come home. So microservices. Covéa is undergoing a digital transformation. It has been for a little while now. That's introducing new technologies and processes into Covéa. We're looking at replacing existing systems. We're looking at introducing new products, new ways of providing a great insurance service to our customers. We're looking at new ways of doing business. So I guess everyone's aware of the various affinity partnerships that we sort of have currently and are looking at to drive us forward in the future, and offering that insurance as a service proposal into those partnerships. So, what does that mean? It's not necessarily taking the whole lot, policy, quote, buy, claim, underwriting, pricing, everything. It's yes, if they want that, we can offer that. If they don't want that, we can offer slices of that. If you just want to look at, Covéa possibly providing a pricing service, or Covéa just managing claims, then hopefully the way we are designing and developing these services, we should be able to deliver that at some point in the future. And through all of that, microservices play a sort of a key role. They underpin that technology platform. They are the individual applications that will deliver those services. And obviously there's a lot of supporting tools and technology around that in terms of the platform, but it's the microservices that will deliver the functionality, if you like, and manage the data. By the way, in terms of questions, if anyone has a burning question to ask, just there'll be a slight pause as I go between slides, etc. Feel free to jump in if it's going to be a quick one, or just leave questions sort of till the end, and there'll be time at the end to talk about this in more detail. So bearing in mind the journey that Covéa is now on in terms of its digital transformation, what are we going to talk about today? So first thing, a quick refresher on microservices, or on a microservices architecture. What is it and why do we do it? It's always worthwhile occasionally just stepping back and thinking and reviewing previous decisions. What have we done so far? So we'll have a quick look at Aaron and what we've done for that. And then more importantly, start moving into what's next. How are we going to move forward with our microservices architecture? How we're going to evolve that into, the Covéa core microservices platform, which will give us access to that insurance as a service proposition. And I'm going to pick out. There's obviously that's a huge subject to cover all of all of the microservices, all of the technologies that support microservices. So I'm going to pick out a couple of areas of interest, which I think are really key as we move forward into developing that core platform. One is domain-driven design, which I'm very passionate about. We'll have a look at that and a simple example, a non-technical example as it happens, and how we knit together microservices. So, one of the key, I guess, one of the main issues I think that a lot of people have with microservices, and certainly we've had our own problems with Aaron at times in terms of microservices, is how they all knit together. So how do you maintain that desired state of having loosely coupled microservices with the actual reality of having to provide a coherent, cohesive system to an end user? And then finally, if there's time, we'll just have a look at some of the options around how you actually deliver a microservices architecture. So, what are the options available if you're doing something, a new product from scratch, or if you're replacing some legacy type services with microservices? How do you approach that? So into the refresher then. So, microservices, one of the things that will always be talked about when you talk about microservices architecture is they are, the aim is to replace monolithic systems. A monolith being an application where all of the business logic, a lot of the presentation logic is wrapped together in one, or at least a few, a small number of applications, which together wrap up all of that business logic and data access and front end rendering, for example. So you may have that monolith, and I use that in quotes, as you may have done it using a sound approach like MVC, where you're splitting out the presentation, the business logic, and the data access. And you know what? If done correctly, there is nothing the matter with monolith systems. They may be the right answer to, products or services that we want to develop now. If we want, if it's going to be a smallish system that has a very sort of definite use case, and the best way to approach that is to wrap that up in application, that could be the right approach. However, I think experience has shown us that over time, especially with the more complex systems, as the code base builds up, as people come and go from the enterprise, as things get forgotten, that business logic and that code base becomes very difficult to manage. It becomes difficult to change and test and do releases on. And adding all of that together, it ultimately becomes a bit of a blocker towards innovation, towards moving the company forward. The amount of effort involved in changing something sort of masks the benefits that you would get from doing new. And so this is why we look at microservices. So a microservice architecture will take that monolith application and split it into its constituent parts, so that all of the core processing are handled by discrete smaller applications. So for example, you might have an application that manages your customer resource. So everything to do with customers in terms of name, address, all of that sort of stuff that you would gather around a customer. The ability to create a customer, update a customer details, view a customer detail, all of that is encapsulated within a single application. And what that means is, when we want to make a change to that single application, all we're doing is changing that one thing. We're not affecting the rest of the system. And clearly there are some caveats to that. If we change how that customer application is accessed by the other parts of the system, then yeah, there's some impact there. But that can be managed through version, different releases. So you can have a version 1, a version 2, etc., and have some sort of strategy where you will support current version and a couple of older versions. But ultimately, it improves that release cycle. So you can push new features, you can do that perfective maintenance, bug fixes, performance tweaks in isolation from the rest of the system, and get a much faster cadence in doing all of that. So I said, microservices, they encourage, by being able to do those releases quickly, by being able to look at small areas of the system, it almost encourages innovation. It encourages that, try something. If it fails fast, so what? It's a small part of the application. It was fairly cheap to do. You can roll it back, and then you can try again something else. It encourages that sort of iterative, innovative behavior in technology. But microservices are not without their complexities, obviously, and we've seen a few of these come and go as we've progressed over the last year or so. They are, when it boils down to it, distributed applications. They all exist as their own individual applications, and as such, there are issues possibly around joining all of those together into a coherent system, into something that, as separate parts, forms a single usable application that is meaningful to the business. How do you knit together the data when, your customer application and the data that's within that, it doesn't know that it's part of a policy. It doesn't know that it's part of a log in a finance system. It just knows that it's customer. So there are issues around that. The microservices themselves need to be hardened to exist in the environment that they work in. So these are distributed applications. If they are calling out to another service, they need to be able to manage any failures, the fact that that service isn't available. They need to be able to do retries and all of that sort of, good resilient type behavior that you would expect from an enterprise application. All of that needs to be built into the microservices, so that you don't end up with an even bigger hell than you had with your monolith when it comes to doing releases or just generally managing the health and performance of that microservice estate. So what have we done so far? Well, Aaron mainly when it comes to microservices. Aaron, for those of you who may not know fully what it is a quote and buy and policy administration platform. It's actually multiple platforms. It's a customer facing front end delivered by our affinity partner. It's a policy administration system delivered by one of our delivery partners, IotaTech, and it's a set of services around integrating all of that and around providing reusable correspondence, payments, billings and finance services that have been developed within Covéa, which altogether forms that Aaron offering. And that's just the image at the top of the top right is just a small snippet of what that overall picture looks like in terms of the microservices that have been developed and hosted within the Covéa environment. So as said, within that, we've focused on developing some very reusable services around card payments, installment plans, billings and finance, which provides a consolidated view around all of those payment services, as well as things like correspondence. So all of those services will be something that we'll be looking at taking into core and making full use of as we start to develop our own policy admin system, claims admin system, and everything else that forms that new core offering. And that little logo cloud in the bottom right corner there just gives an indication of the amounts of involvement, technologies, tools that are used on that platform. So you've got the the various delivery stakeholders, Covéa themselves, we've got And Digital, who we work with, Emerging, IotaTech, and then the microservice development technologies themselves, so .NET and Node. We have Kafka there, and then all of the various supporting tools and technologies. So it's, when you start looking at it like that, it's quite a complex environment. And I think anyone involved in Aaron, take a moment, sit back, have a little warm feeling. We're not finished yet, but I think over the last year, we've achieved quite a lot in terms of delivering that platform, which will not only deliver Aaron, but also set us on our way for the overall Covéa core offering. Oh, next slide. I won't talk about this one. If you get the slides afterwards, that just gives a sort of an overview of the whole of Aaron, the different platforms, the different capabilities, the integrations, and how those integrations, what types of integration there are, but too detailed for this particular talk. But I guess the main part of this is what's coming next. We've gotten so far with Aaron in our first stab at a microservices architecture. We've done some really good work. We've got microservices out there working. We've learned a lot, but how do we evolve that? What are we going to do that's new? What are we going to tweak? What are we going to amend that will allow us to continue up that maturity curve of microservices? And I think the first thing to note is, this is already happening. We've already started, if you like, looking at core and everything that's going to be and how we're going to start approaching that. We're already having discussions around what are the new technologies that we may need to bring on board to help us on our way. And again, this is a big list. I'm not going to go all the way through it. It's there in the slides for you to just have a read through and think about the sorts of things that we're going to be looking at maybe evolving into in the near future. So things like moving towards a more event-driven architecture, which will give us even more capability to scale our microservices, have much greater reuse out of those microservices. It totally decouples the services from one another, and I'll come on to that later on in the presentation in a little bit more detail. But there's also some additional talks been happening around events within Covéa. So Dan Ruck has already done a talk on that, and I think there's another one in a couple of weeks' time around events. Automation, we do it. We have our CI/CD pipelines, we have automated builds and testing, but you know what? Until it's almost hands off all the way from the developer laptop through to production, there's always more we can do, and that allows us to really speed up those release cycles and just gives us that much greater level of quality assurance around what we are pushing out there. I guess other ones on there, CQRS, so command query responsibility segregation. In its sort of most detailed form, it's a coding pattern. I think you can lift that up a bit to a bit more of an architectural view, or a bit more of a design view, and look at it as having microservices whose job is to provide read-only views on data within our microservices estate, to separate them away from that the more sort of heavy lift, create, change, delete type processing that goes on within the operational microservice. And you can take that even further into providing, where needed, aggregated views across services. So this might mean using things like, if it's purely a virtual type view that you want across a few microservices, using things like GraphQL to knit together a presentation type view from a number of different microservices, or using things like graph databases, which really well define those relationships between data and provide a much more sort of persisted view of data from across different services. They're the sort of tools that we'll be looking at to grow our capability in this microservices and API type area. Data is massive to Covéa. Using data in the right way can bring huge amounts of benefits, in terms of things like next best actions, getting the most effective pricing models, driving how we determine how we manage risk, and how we quantify risk. All of that can be greatly enhanced by data, and as such, Covéa is making quite a lot of investment in that area. So the question would be to anybody involved in microservices: how can we, as the developers, as the testers, as the designers of microservices, how can we make sure that whatever they do, we're able to leverage the data that's generated by those microservices in the best possible way to further drive forward the business. And some of that is handled in things like being more event driven, making sure that we have an effective event stream between the operational microservices and the data lake and all of the data and analytics that hang off that. So that's another challenge that we'll want to look to drive forward with. And then the last one there, instrumentation and monitoring. We have some at the moment. We have a good logging capability within microservices, but I think there's more we can do in that area in terms of having a really effective way of understanding what happens within those microservices. That really does improve our DevOps capability by understanding how services perform. If an error occurs, being able to diagnose that really quickly and fix that quickly. So something that shouldn't be forgotten about. So moving on to some of the more detailed areas I wanted to have a look at. Domain-driven design is the first one. Now, I've got a quote there from a really good book, actually, Implementing Domain-Driven Design by Vaughan Vernon. It makes software as close as possible to what business leaders and experts would make if they were coders. So the thing about domain-driven design is, yes, it's abstracted from the code. It's a design model. It's not code in itself. But the way it's approached is in very much a sort of a pragmatic style. It's somewhere where developers, analysts, business operations people can get together and really understand what they want the business to be and how to model how that should look, and then keep on iteratively drilling into that until you get to a point where within your design you've got the main areas of interest, and this diagram that I've got on the screen now is very much the highest level of a domain design. It shows those key areas that are important to the business, but within each of those there are other what we call bounded contexts which go together to make up that domain. So risk, for example, within there you could imagine there would be things around motor risk, pet risk, home risk, various other things that will determine what the behavior is, what the data needs to be, what the interfaces need to be to ensure that it exists within the overall business sphere. And when you get down to that level, the reason why I've got domain-driven design here for microservices is that it really does define what the microservices need to be. When you get down to those fairly low levels of abstraction in the model, you know, and you have your motor risk or your customer sort of entity, that will be a direct link into a microservice. You know, you will end up with a microservice called motor risk, for example. And as part of this model, you will, as part of that, define how that motor risk microservice needs to interact with, you know, the higher level risk service or into policy as well. And some of the, I guess, key principles of domain-driven design. Ubiquitous language. It sounds like a big thing, but it really, you know, in its simplest term, it means when people get together to do these domain designs and talk about what's important to the business, they use a common terminology. And so, for example, you know, within the bounded context of, say, claims, you know, they will understand a payment as being something that is made to a customer. They will understand, you know, risk as being, as, you know, something else. And that's the whole point. It allows business operations people and technical people to talk about things in the same way. And so concepts don't get lost. Requirements don't get misunderstood. It removes the ambiguity from those requirements. And the other one that I've got down here is bounded contexts. So that is something where, as you drill into these high-level domains, and, you know, as I said, risk is a reasonable one. There'll be things. In fact, we have an example on the next page. This is just a snippet of, you know, the next level down for policy. It's not all of it. It's just something I've pulled out just for this example. We're starting to identify some of those bounded contexts. So, you know, a term, a section, a cover within an insurance policy. You could almost imagine, you know, a microservice existing for each of those. They will maintain all of the data, all of the processing that's required to manage that particular data item, or that entity. And as you can also see by the lines, you're starting, even at this fairly high level, to describe what the relationship is between that and other entities. And once you get down to the very detailed level, you know, you'll be defining actual interfaces. And this is something that, certainly from our experience, has been difficult at times. So we didn't have a full domain model for Aaron. And while we were able to, you know, effectively develop individual microservices to meet the requirements around things like installment plans. So, you know, we knew everything there was to know about installment plans. We knew everything around, you know, how to do collections and direct debits, etc. But where the missing part of that was, how does that knit into the wider system? So we want to make it usable by the policy administration system, by quote and buy, but at the same time, you know, manage that single responsibility and that sort of that level of discrete operation. And this is what domain design does. It makes you think up front about how that service will be an independent service, but which will interact with the wider system. So I've got a very quick little example here around domain-driven design, using entirely non-technical. Well, it's a non-technical example. As you can see, it's around, you know, rooms, designing a flat, say, and at the start here, we haven't done a domain design for this. We have our list of components, possibly a list of microservices. Each of these is it's a modular component. It has single responsibility. It contains all of the functionality that's required to perform its job as a kitchen or a bathroom or a living room. But as a set of discrete components, it's not delivering any value at the moment. It's just a set of rooms. So we just push them all together, right? And we've got a flat. We use our components. There you go. We've built the components. There's your flat. Does that work though? Do the components integrate well together? Do you have a good user experience? Is the flat livable? Some of it is. You can get to the bedroom and the living room from the hall. You can get to the dining room as well. But to get to the bathroom, you've got to go through the dining room. And I'm not really sure what the kitchen's doing, but you just can't get to that from inside the house. So while we've got some well thought out components there, because we didn't have that design which told us how these components need to interact and what the relationships are between the components, what we've delivered there is a failed flat. It doesn't work. It's not really livable. So if we spend some time focusing in on what those relationships are and what the interfaces need to be, then it does reap benefits in the end. So you can spend a lot of time, focusing in on individual components, but without that advanced design consideration around how it all knits together in different ways, then ultimately you'll have problems when it comes to delivering that coherent system at the end of this. So what we have there are the same components, but slightly different configured, so that we have, kitchen and bathroom next to each other so that utility services can be shared. The dining room opposite the kitchen, get the spag bol on the table, piping hot, as it were. We've thought ahead and we've delivered a usable, coherent system. And the same thing applies for microservices. While it's all well and good defining those discrete units, we need to complete that with a full domain design to cover off how those interact with each other. And that doesn't necessarily mean, understanding, to continue with the flat analogy, what the rest of the building looks like or what the street looks like that the building sits in. You can separate out individual areas. You could, using our policy model, you could look at risk in isolation. Yes, you would need to understand how that connects to policy, but within risk, you could focus in on that and deliver that set of services, understanding how they integrate with each other and how they need to behave before you deliver, contact or policy in the main. So that's domain-driven design, and I think you'd probably need to go in, if you haven't already got an understanding of that, I would say it would be very worthwhile everybody diving into that particular approach to microservices. There are some good books out there. I can certainly point people in the direction of books and training courses around that. But moving on to the next one, events and orchestration. So as I've said, a lot of the focus is on how microservices knit together. And one of the ways we've done that so far is through microservice orchestration. So on the one hand, we want to keep microservices as discrete units so that they can, we get all of those benefits around fast release cycles and low impact changes. But at the same time, we do need to bring them together into a single system. And the way we've done that with Aaron is through microservice orchestration. And what that means is it's almost to coin a phrase, an anti-pattern, in that we take a microservice, we build a microservice, which is its role is to coordinate the behavior of other microservices. So if you have a business process that involves, getting some information from your contact microservice, updating policy microservice with something from that customer, and then passing the whole lot onto yet another service, then we've developed a microservice in itself that will have an understanding of that business process and will call in sequence each of those other microservices. Now, as I've said, that's almost a bit of a no-no in terms of developing microservices. It builds into that orchestration microservice the sort of the in-depth knowledge of how other services exist and work and what their interfaces are, which is normally something you wouldn't do. But when it's approached, fully conscious of what you're doing and in a limited way, then it is a reasonable way to approach having that sort of bringing those microservices together and building business processes across different microservices. However, as we move forward, we want to start replacing orchestration with more event-driven microservices. So what that means is where previously, you would have this orchestration service sitting above, say, 3 or 4 other microservices that will call them variously and aggregate responses, etc. With event-driven, what that means is the microservices have no knowledge of each other. They will be triggered by something, possibly an event, possibly an API call. In response to that event, they will do some processing and then push their results onto the event stream. And then that will be consumed by another microservice or other microservices, which will then also, do its processing, put the results onto the event stream and carry on. And that gives us a few benefits. It means, our microservices at that point are as loosely coupled as we could hope for them to be and are therefore very scalable. We can add and remove microservices without any impact to the rest of the system, which will consume events and produce events. And as long as they comply with those event schemas, then everything will be fine. It allows us to have those faster release cycles and a greater level of modularity in the microservices. So as long as you are conforming to those events, if you make changes to your microservice, then all will be well. Integration is better. It is very beneficial in terms of getting the most out of microservices for data and analytics. So, all change events could be consumed by your data and analytics services, and then data scientists go to work on that to see exactly, how the business processes run, how all of that good work around data, which allows us to, as I mentioned earlier, drive forward things like underwriting and pricing. And it also, because these things, once we get into a mature event-driven architecture, again, it's yet another way to encourage innovation. It allows us to very simply add new microservices into the mix, which can then be consumed by other services, other applications. Again, there are always some downsides. The complexity in event-driven architectures is that, the fail scenarios. If you have a logical chain of 3 or 4 microservices where one thing needs to happen after the other, if something fails halfway along that chain, then you need to build in some compensating event which will allow other microservices to know that something's failed and to either roll back or make whatever changes are necessary to compensate for that failure. So it adds a fair bit of effort into that initial design around the microservice architecture and those, well, not just the architecture, the designs of how this all knits together. You know, what are the events that are needed? What are the compensating events? What are the business processes that will drive these? And but again, you know, some of that can be tied together by external system stakeholders, if you like, things like workflow services, which can sort of interact with that event stream, that event queue, and help tie together some of those microservices that need to actually do the work. So as we move into a more event-driven architecture, certain things will come to the fore. We'll do things in a slightly different way, or maybe not different, but certainly tweaked from how we currently do them. So things like Kafka becomes a little bit more important than simply the event queue or the message queue that we use it for currently. You know, we might want, with the increased importance on events and the level of criticality around making sure that microservices conform to defined schemas so that, you know, we protect the microservices, we may start using things like Avro and schema registry within Kafka to govern that. You know, so to make sure that if as a consumer you push an event onto a topic within Kafka that doesn't comply with a predefined schema, then Kafka will reject that. It will protect those downstream services. And as we scale up in this area, that sort of, you know, automated governance is essential. We'll probably still use orchestration in limited areas where it makes sense. We'll use it. And as I said, things like CQRS and graph databases can be driven themselves by you know, a much greater use of events. So as change events take place, it would update the graph database and provide that sort of consolidated view of data across services. I think the other one in there, event source. So using an event log as a way of presenting data. So by that I mean every change that happens to a piece of data within a service would generate an entry into this log, and to see, you know, what is the state, what is the current state of that object. It would be a case of, you know, you almost replay those events to get to the current state of the object. Now that can sometimes be a little bit wasteful, shall we say, if every time you want to understand the current state of something, you have to replay the whole sequence of logs to get to that place. But there are ways and means around that. You know, one of them I've mentioned is using CQRS to present a sort of a fast access view of current state. Within event sourcing, it has the concept of projections, which is actually a similar thing, you know, keeping the current state persisted so that you can either view that or go back and read through that log. An event source really does make sense for things like claims, for example, where, you know, a claim is a set of activities that happen at different times. You've got your first notification of loss, you'll have some repairs, you'll have some, you know, payments to third parties, you may have some disputes. All of these will go together to make up that log of the claim, which can then be displayed in a claims application however you want it. If you just want the latest state, it's there. If you want to be able to read through that, that's possible also. So yes, greater focus on event-driven architecture going forward. The final thing, as we wrap up, just a very quick one around delivering microservice architecture. Different approaches, what their various benefits and things that are not so beneficial are. So I've listed a few there. So there's the classic big bang approach, delivering everything all at once, and what the benefits are around that in terms of, yeah, it'll get you the fastest time to where you want to be. You can focus purely on delivering new, but you know what? It takes a while to deliver, and there's also that risk as you go along, things change around it, which you'll have to react to. A slightly more microservice friendly approach, if you are replacing an existing system, is legacy strangulation or decomposing monoliths, which is longer to get to where you want to be in terms of your target state, but you deliver that by replacing areas of functionality. So to stick with claims, for example, first notification of loss could be removed and delivered on the new platform as a separate, application, and then with some fairly broad-grained integration into the legacy system at the end of that process. Now, while that reduces the risk of delivery and reduces the risk in terms of, you delivering smaller chunks of work, it increases the complexity in that you're going to have legacy integration and potentially people working across multiple applications if you're delivering something on new and something on old. And then the final one I've got there, legacy modernization, which, yes, takes the longest time to get you where you want to be. It might mean making changes to your legacy estate and only swapping things out when an opportunity arises. It really does reduce risk, but at the same time, it can be very complex in terms of, how you can develop at a very fine-grained level microservices along with changes to your legacy estate. And I think, I'm not advocating any one of those. I think they're there just to inform in terms of how we deliver microservices architectures into an enterprise. And the reality is often a combination of all three of those, where you would, use whichever is the best for a particular point in time or for a particular service. And that is it. Does anyone have any questions around the presentation? I will, of course, put the slides on and make them available. And everybody knows how to access me through Slack. But if anyone has any questions, I'd be more than happy to take a few now. I've
got one, Phil.
Yeah.
Richard. So you talked about if we're using a event-driven architecture, if something goes wrong, you can roll back effectively by producing rollback messages.
Yeah.
So REST is stateless, so they don't have any transactionability. So how we're not doing the event-driven architecture as well in total currently. So what do we do about rolling back currently? Say if you've saved a policy in the payment files, you've already saved the policy. What are we doing in that circumstance?
So as I said, we use orchestration services at the moment. So the orchestration service will directly call its child services, if you like, in whatever sequence is needed. And if any of those fail or you get a response that is not on the happy path, then it will be the responsibility of the orchestration service to ensure that the data, the entity is left in a consistent state. And similarly to, if that orchestration service sits between, IOTA Tech and our payment services, it will then, put everything back into a consistent state on the Covéa side and push back, some sort of error message into the consumer side, the IOTA Tech side. So it's very much handled by those orchestration services.
Okay. Cheers. Thank you.
Yeah, quick question about external services. So you mentioned one of the complexities is managing the interaction between microservices. I'm just wondering what the strategy is for external services and things like Kong endpoints and IOTA tech, and reaching out to external services and maybe getting traffic in, because I know that in release 1 of Aaron, it was all done very manually with kind of tickets being raised, but I've heard things from the squads saying that that's going to be automated through configuration as code and that sort of thing. So I'm just wondering if there's an overall strategy and kind of architectural approach for that sort of thing.
Right. So are you talking about sort of integration between services? Or are you talking about sort of the building of the services, or what?
Yeah, so kind of deploying out and building the environment, really.
Okay, so I think the ultimate aim for that is to have that as automated as possible, and I think we're fairly well along that route. So in terms of, you know, building a microservice in a container deployed onto a Kubernetes instance, I think there is a degree of automation there. You're right. I think there's still probably too much manual effort, but we are still in the early stages of all of this. And I think as we go along, we've got the right tools in place to be able to automate further, so that when a microservice is deployed, you know, the API, the published API on Kong, that would also get scripted. It will be deployed automatically. Tests will be run automatically. So I think you're right. There's probably too much manual effort at the moment. We know that is the case, but there is a definite, you know, as part of our roadmap to improving how we do microservices, further automation is absolutely on that roadmap. But I think we have the right tools in place now. It's just using them more effectively.
Yep, that sounds really good. So yeah, it'd be good to get more visibility of that, but I can take that offline. Thank you.
Any other questions?
Phil, I think one of the main concerns of CQRS is eventual consistency. Playing devil's advocate here to some extent, because it's a question that's asked of me quite a lot. How do we manage eventual consistency, in as much as data takes a while to get from the command space to the query space? We can't guarantee it's up to date.
So I think we you know, I think the first thing is to recognize that you don't always need instant updates and have visibility of those instant updates, and it should be very much driven by the requirements, and possibly more importantly non-functional requirements around those particular areas. So if for example, if an application makes a change and then immediately needs to see that change, then you know what, you may not be able to use CQRS in that instance. It may be something where for that one you would need to go to the operational service and read the absolute latest value from there, because that's where that gold record, if you like, sits. But I think for a lot of things, for most things, if we're honest with ourselves, that absolute immediate visualization of changes is not always required, and so eventual consistency is absolutely fine in those cases. I think it also you know, acknowledge the fact that in most cases eventual consistency means probably, you know, a couple of seconds, if that. Obviously, with it being slightly disconnected from the source of the data, it can take longer than that. If anything breaks down in between, any network failures, then you could have issues. But like I say, it's ultimately it needs to be designed in from the start, and needs to absolutely be cognizant of any non-functional or actual functional requirements around data accessibility and how quickly those changes need to be manifested for read. So I think the answer is design.
Yes, excellent. Thanks.
Okay, I think we're into the last few minutes now, so I think it's probably best to wrap this up. And as I said, I'm available on Slack. Feel free to give me a shout anytime about any of this. I'll share the slides through the channel. And other than that, thanks very much for spending some time listening today.
Thanks,
Tasha?
Phil. Thank you. Yeah, we'll get the recording shared as well this afternoon.
Thanks, Phil.
Thanks, Phil.
Thanks, Phil.
Thank you.
Thank you.
Thank you.
Thank you.